This video is designed to show the interactive designs contained within the QuestMB product, along with the optimization process that's used in our automated design. You have the option of doing an interactive analysis of any part of the building. What we're going to concentrate on today is just show you a portion of that in our frame interaction and our in-wall interactive design. So we're going to go ahead and look at our frame interactive design on a building that we've already run, our main building here, which is 50 feet wide, and we have our frame, and it's showing our frame design here with our sizes, our segment lengths, our flange widths and thicknesses down here in the bottom grid. We have our depths located in the top grid. The BL, LP, BR, and RP follow a simple pattern that you can see in our help. We'll scroll down. BL is base to left column, BR is base to right column, LP is left column to peak, RP is right column to peak. All of this is contained in the help, along with the definition of what a segment is and a section. You can find these in the help portion of our software. If you right-click on the report at the top and you click Report and Drawing, it's going to take a couple minutes and it's going to create for us some drawings as well as reports. If you're running multiple screens, you can take this screen and put it over on your second screen. However, since we're only showing our one screen here, we're going to make it a little larger so that we can see what we're going to try to accomplish today. This frame is a tapered frame. What we want to do is we want to make it straight up to where our web intersection is right here, and then we're going to let it taper from there on both sides. This will look a lot better in our design, and this frame is an end frame and it's totally open, so this is going to be kind of a arch on our building. We want to do that for a more aesthetic look. So what we'll do is we'll quit here, and the first thing we want to do is we're going to give ourselves just a little bit more depth here, and we're going to add another depth, and the negative says that we're not putting a connection there. So we're going to go from 12 inches deep straight up, and then taper to 26 inches deep. And we're going to do the same thing on the left column, or on the right column rather. Now we're going to come back up here, and what we'll do is notice we go from we're at 12 feet for the first 12 inches for the first 10 feet. And we can let it optimize and take a look at and rebuild its sections, or we can let it analyze the sections that we've picked. We have that option. By right-clicking here, I can zero all widths, which would let it optimize, or I can pick a size and I can then analyze the size that I choose. In this case, I'm going to just go ahead and let it optimize based on my geometric requirements. Now we have to do one other thing. Since we've added the depth, we've actually changed our segment and section criteria, so this becomes a 2A, and the same thing happens down here. Very simply, we can then run this frame. We're processing, and it's telling me that my connection design is going to be different, and that's okay. It's processing my frames, and we have a new design, no errors. We'll take a look at our new cross sections. While those are coming up, take a look at our frame weight. This is in green at 1874, and we've actually reduced the weight from 1932. So now our frame looks like this. As you can see, it's got the straight just as we asked and the tapered. We were able to do this very simply, didn't have to have a lot of calculations on the front end. The computer took care of all of the optimization based on our geometric requirements. You can do that with any portion of the frame and change different things. Now, suppose during the interaction you think, well, I want to change a load or maybe change a girt space. We can come back in up here, right-click, and edit our job data as if we were just doing an input. So this portion of the frame design, and then allows us not only to do this with each individual frame, we have our 3 designed frames, but we also have the option of changing the design on the connections. So as you can see, the frame design allows you total control over the look, the size, and the need that you have for your connections, as well as your frame. You can not only do that with a frame design, but you can also interact with your end wall design or any other face of the building. For instance, on our end walls, we have 8 by 2.5 Z16s. Should we not want 8 by 2.5 Z16s, we can click, and then we have the full range of girts here available. And we can select any girt that we desire, add sag bracing that we desire. We can do this for the left end or for the right end. We can then take a look at our frame, and we have 10 by 4 C12s, and we have total control of the sections too. If we wanted to see if we can't go down to a 10 by 4 C14, we can change that and then have it analyze the right end wall columns, and you'll see that they were designed as overstressed. So it will not allow you to make the change that you want to make and without telling you whether or not it was overstressed. If we get into a pickle and don't know what size that we started out with originally, we can just tell it to come down here and design the right end wall column, and it will do a full optimization process on the right end wall columns just like it did when it first came through. On the end walls, you also have the option of interaction with your connection design. You have this with every elevation. With every elevation on your building, you have your roof interaction design, your sidewall interactive, end wall interactive, framed opening interactive. Even our partitions have an interactive designs. So you have total control as the engineer or the estimator over what your building looks like in your design. The process is so user-friendly that many estimators use this process to do their own designs and do their own changing to get the customer requirements as far as frame geometry or building strength. They use their own interaction, and they do this themselves, saving time to have it go back and forth to the engineer. This concludes the interactive design portion of this video.